Good afternoon and welcome to SolidCAM Technology Centre here in Barnsley. Very warm welcome to you, and thank you for taking the time out this afternoon to look at our presentation. For those of you who didn't realise, this is the second part of the presentation. The first part of it was a live face-to-face this morning, which went very well, was very well received by both partners and by customers who turned up. So that was very, very good. So now we've got an extension of that, and this is where we're spreading it out to a lot more people who were unable to make this morning. And we've asked our partners from this morning to stay on and give us a little information this afternoon. We're just going to have a general chat with all of those. So big thank you for them, for their efforts on that. Much appreciated. So the plan for this afternoon is very informal. We're just going to have a nice little chat on there, but we're going to show you some presentations as well, so there'll be a lot of information. Opportunity for you to ask questions as well, so again you can type your questions through the internet to us. We're going to be running some presentations on there, so we've got our two machines set up. We've got the Star ST20 over here, which we'll be running a presentation on, and also running some interviews on, and also we've got our Romy D1000 over here, which we'll be running an iMachining presentation on as well. So I won't waste any more of your time. We're going to go straight into a presentation on the iMachining, and then we'll come back with Andy and Graham, who will be conducting the interviews. So big thank you to everybody for joining, and big thank you to all the people here who've made it possible. Thank you.
So I just want to start with a quick presentation about iMachining first. Then I'm going to show you how I've programmed some of the elements on this component and how easy it is to use iMachining before we go back to seeing it being live cut in our technology centre. So iMachining consists of two modules built into the operation. We've first got the intelligent toolpath generator, so this calculates the efficient morphing spiral toolpath. And then we've got the technology wizard, which is the second half of iMachining, which automatically calculates the varying cutting feeds, the speeds, and the point of cutting on each toolpath. So what we're aiming to do there is maintain a constant cutting force on the tool, and this is where we vary the cutting feeds. Now, the reason that we vary the cutting feed is because we vary the cutting angle as well. So the contact angle, you've got a minimum and a maximum contact angle, which is set inside iMachining. This is set automatically for you, so the toolpath will be calculated based on these angles, and then we also vary the cutting feed to keep a constant force on the tool. So when we've got a smaller cutting angle, we will increase the feed rate, and when we've got a larger cutting or contact angle, then we will decrease the feed rate. We've also got two additional patented unique features inside iMachining as well. So the morphing spirals in iMachining, again, they're patented, so that is the one side of it, and we've also got the intelligent separation for iMachining as well, what we call channels. So you can see there on the right hand side, what we've done is this area here to maximize the amount of area that we're going to spiral toolpath. So we're going to use the morphing spirals. We will cut a channel down the wall, and then we've cut two channels in. Now this is all done automatically by the operation, and then you can see there, once we've cut those channels, we're left with three islands, which we can then use the morphing spiral toolpath on to cut those areas out. Again, the user doesn't need to do anything. This is all automatic by the operation. It detects these areas and it will create those channels and islands for you. So the technology wizard, this automatically takes the guesswork out of CNC machining, basically out of high-speed roughing. So the spin, the feed, and the step overs and how deep to cut are all automatically calculated. So we give it the information, so we give it the material, the ultimate tensile strength of the material, we give it the geometry, we give it the information about the machine, so this is set from a post processor, like the maximum spindle speed, the power at the motor, and then we set the tool as well. So with the tool we would set the angle, so the angle of the helix, and we would also set the length of the cut and how many flutes it's got as well. All that information is fed into iMachining, and iMachining then calculates the speed, the depth of cut, the step over, and the feed rate, and in turn we then calculate the G-code afterwards. We've also got an iMachining slider bar, levels 1 to 8 inside iMachining. This is the metal removal rate, so 1 being the minimum metal removal rate, 8 being the maximum metal removal rate, and then 2 to 7 are associated in between those two metal removal rates. Now, the reason for the iMachining level is that we can slow down the toolpath but still gain all the benefits of the iMachining logarithm. So we've still got the morphing toolpath, we've still got the constant forces. However, we may not have the part set up rigidly in the setup, so we may slow it down, the machine level down, or if we've got it super rigid, we've got it in perfect conditions, we'll be up at the 8 mark, which is what we're using today. We're nice and solid on the bed, so we'll be machining at the level 8. Now, the axial contact point is what iMachining is using to calculate whether it is a good toolpath. So you can see here we call it ACP. ACP nearest to a whole number is the conditions we're looking for. So you can see on the left there we've got a few contact points, just one contact point on there. Yeah, this is why we need to give it the tool information, i.e. the helix angle and how many flutes it's got, so we can calculate where those contact points are. On the right hand side here you've got ACP 1, 2, 3 and then 4.5. Now, if we had that at 4.5, the software would tell you that it would be in the orange or the red area, which means you are going to get some vibration. So we'd advise not running that and using a different tool where you could gain an ACP closer to a whole number to get nice and green. I'll show you that in the software shortly. Couple of little customer successes just to show you. iMachining 2D savings in aluminium. So first billet here, the depth of cut 38mm. The customer was cutting it in 17 minutes. Now with iMachining it's down to 6 minutes, so we've got 65% saving, 73.5 hours nearly, over 400 pieces that they were creating. And then right up to titanium, so in your harder materials this is where you'll gain the most cycle time savings. So standard cut time 17 minutes, now with iMachining we're cutting it in 3.5 minutes, so 80% cycle time savings, nearly 17 hours over a total of 75 parts. So let's have a look at the component we're cutting today, and we've got it set up here in the shunt single pot, clamp down, and we've got some iMachining operations on here. Now the first one here is this pocket here. Now I just want to show you how easy it is to select the geometry. So the way that I've selected the geometry here in 2D iMachining is I've used the feature recognition by faces. If I just unselect this, all I need to do, select that bottom face. It knows the area now that we're cutting because it knows where the stock is, and we've selected the tool. So the tool that we've got here is the 12mm cutter. It's got 36mm cutting length on it. And let's go straight to the technology wizard. So the technology wizard is nice and green, close to a whole number with the ACP, like I was saying in the presentation. 29.7mm depth of cut, so full depth of cut on there as well. And you can see here where it sets the speed, maximum speed, feed and step over. So this is the maximum feed rate. It will fluctuate depending on the contact angles, and this is the minimum and maximum step over depending on those contact angles. We go to view 2, you can see 174 meters at 0.07 chip thickness on there. Maximum contact angle 32 degrees, minimum 15 degrees. If I have a look at the slider bar, so we're up at the 8. Like I said, if we weren't so rigid we could slow this down, so you can see the numbers will change with each other. So we could go right down to the number 1. Yeah, we got speed and feed and step overs here, and we can go all the way up to the maximum metal removal rate, number 8. If I calculate that, see that's created our toolpath on there. I'll show this in simulation. So solid verify, you can see this is our lump and this is our toolpath pattern. So you can see that morphing toolpath, we're keeping a constant cut. You can see here as well the feed rate is constantly changing. We've got high feed rate as it comes back, so it's always climb milling. It lifts up a little bit by 0.07, lifts up, and it goes a high feedback pass back. So that is our first one there. And what I've done in this little demonstration as well is I have created some steps up here just to show the difference in the levels and also the cutting at the machine when we go full depth and when we're only going small depth. So we've got some change in ACPs in here, so we'll just calculate all of these for a second. So we've got these steps here, and on the fifth step, so the top step there, yeah, you can see if I look at the technology wizard, SolidCAM is telling us that it is not ideal conditions. You see it's red. We are going to get vibration there. What I've done is I've taken the machining level down to 5 for the purpose of this demonstration. Now ideally I would not run this at red, but for the demonstration I just want to show off on the machine the difference in the noise that we get here, and you can hear the vibration. The software tells us we're going to get vibration. You do actually get vibration in that section there, so it would be wise to use a different tool so that you get better ACP in that area. Now that's iMachining, but just one last thing to show you as well, which is the deburring of all these edges. Now I want to just put an edge break on every edge of this component. Now all I need to do is automatic deburring recognition, yeah, against the whole solid body. I'm just going to select the solid body, and it will pick up every edge on that solid body that I can deburr. Now I don't want to go around this edge here, it's too tight to get the tool in, so I'm just going to unselect that one and I'm going to OK that. Now what I've also done is as well, I've put a gouge protection offset of 0.5 on the whole target, so on the whole model, yeah, so that when we come down here with the tool, we keep the edge of the tool 0.5 mm away from this edge here, so we don't bump into anything. I've selected the tool, and on technology I've told it to do a cut diameter of 1 mm, and in levels I'm doing a chamfer of 0.2. So if I calculate this, and you can see I have chamfered every edge on that component without too much effort. So you can see here, we go all the way around, no collisions. You can see we stopped short, so we've got as close up to that edge as we can get, and every edge on there as well. So let's have a look at some live cutting back in the Technology Centre.
Thank you for that, Ben. Good afternoon, everyone. My name's Andy. I'm one of the business development managers here at SolidCAM UK. One of our machine tool partners, Romy, unfortunately can't be here this afternoon, so they've provided us with a short video, just an overview of their company.
Good afternoon, everybody. My name's Graham from SolidCAM, and welcome back. We're going to be doing a few interviews with some of our valued partners, and first up this afternoon is going to be Ian Cooper from ISCAR. Good afternoon, Ian.
Afternoon, Graham.
And thank you very much for attending our SolidCAM live event. It's very much appreciated.
Not a problem. Thanks for the invite. It's been a good morning so far, so hopefully that carries on this afternoon.
Yeah. It has been a very good morning, and so just going to pop you a couple of questions about what's been happening today. We're using the 7 flute today for the iMachining demonstration. Can you elaborate, give us a bit more information on why we're using the 7 fluter this afternoon?
Yeah, of course. As you say, Graham, that is the 7 flute tool. It's a full range of product. It starts at a 2mm diameter, goes right the way through to 20 diameter. It's a 7 flute. It's got differential pitch on the flute spacing and also variable helix angles on the tool itself. So again, optimised for maximum metal removal rate, vibration-free machining, and as I say, it starts very, very small on 2mm right the way through to 20, and from diameter 6mm upwards, we actually do it as a 2 times D length of cut, 3 times D, 4 times D, and 6 times D length of cut. So, for example, on a 16mm tool, we have up to 96mm of length of cut. So again, using software such as the iMachining, we can really optimise maximum metal removal rates.
Ah, very good. That's quite a comprehensive range you've got there.
It is.
What would be the benefits of the ECP geometry?
Well, the ECP geometry is an expansion of the EC H7 range. So again, it's an ECP H7, so it's also 7 flutes. And the P in the description designates that it's actually a chip splitter geometry. So we have chip splitters all the way throughout the range. This product range starts at 3 times D, 4 times D, and 6 times D. So again, it's all about maximising metal removal rate. And with the chip splitter geometry, this just makes a smaller chip, so it's easy for chip evacuation. It also enables us to give greater width of cut and also higher potential feed rates. So it really does, again, further optimise and maximise metal removal rate for high production environments.
Excellent information, Ian. Are there any recent additions to the solid carbide multi-master range that you'd like to elaborate on?
Yeah, thank you. One of the latest innovations that we've come up with is our barrel mill range. Obviously, this is a new technology in range as regards machining techniques, but we have introduced it to our solid carbide range and more importantly to our multi-master range. So the multi-master range with the indexable solid carbide heads is really a fantastic use of just the small actual cutting zone of the tool, which minimises scrap and cost. So it really does optimise the benefits of the barrel milling technology and strategies, but again, just requiring the small amount of carbide that is actually doing the cutting.
Keeps you on side with the green people.
Exactly, yeah, and obviously with the environment and other issues like that being so important nowadays, anything that anybody can do to help this is obviously a massive benefit to everybody involved.
Absolutely. Well, Ian, thank you very much. That was very enlightening, and I'm sure the viewers will be very interested in that you've elaborated and you've shown us what all this is all about this afternoon, and the technicality in the ISCAR product range, which is a very, very good range. Thank you very much once again for coming along. You're very valued to SolidCAM, and hope we do some more in the future. Thank you
very much.
Hello everybody, moving swiftly on. Another one of our very valued partners from Shunk. We're going to be doing an interview with Marcel Mercado. Good afternoon, Marcel.
Good afternoon, Graham. Nice to be here. Thank you for this.
Sorry?
Nice to be here. Thanks for the opportunity.
You've just stole my thunder there, because I was going to thank you very much for coming along. And thank you very much for your support once again. You've always been there for us, and hopefully it carries on.
It was a pleasure.
Again, today we've been shown on the ROMI the ZeroPoint. Could you give us a bit of information on the advantages of using ZeroPoint, Shunk ZeroPoint?
Yeah, so ZeroPoint is something we've been using in this place for a while now, and always for the same reason. So the ZeroPoint, for those who don't know, it's a drop and lock quick setup system for your CNC machine tool. So mainly used on a vertical milling machine as today, but it does have other applications we use with jigs and automation and everything else. In essence, it's a pneumatic system. There you have a pin that goes into a plate, so it's air to unlock, so it doesn't need any live feed. So once you have your fixture in place, you can disconnect everything from the machine and just run dry. You can normally, the most common use would have you have a vise or a other kind of fixture that you can mount the pin onto, and then you can do a very quick change of setup. So you would have machine running, you have an external setup, your offline setup. As soon as that finishes, you plug somewhere, take that off, and put it back in. That's where the people who are familiar with it, that's normally what they would think about. Today, we're doing a less common usage of it, where you went directly into the billet. So you drill the billet, you put the pin on the billet, and now it's gone directly into the system. So the ZeroPoint can be your only fixture as well, depending on the application. And one of the reasons why we keep showing this here is because we think it's the best thing since sliced bread. Of course we do, we make them, but it is a really the best kept secret in the industry. We are always surprised on how little people use ZeroPoint. So we, in Germany, in our own factory, we use ZeroPoint for absolutely everything, because the return of investment is always there. So it's something that is difficult to understand until you actually see it. Even if with the demo here, until you actually touch it, you don't really appreciate how beneficial that can be. So we do invite people to call us, and we'll drop a demo, and and then people can have some experience with it. And then, that's in essence that.
Thank you very much, Marcel. Is there any? Tell us about the SPM diaphragm clamping and where you would use that application.
Yeah, so this is an accessory for the ZeroPoint. It's fairly unique to Schunk. It's like the name says, a diaphragm. So you have an aluminium fixture that can be machined to whatever shape. So the most obvious usage for it is when you have a particularly awkward profile that you need to hold there. A vise, a normal vise wouldn't do the job for you. So not round billets or square billets, but any free form. But other than that, it's also very useful for using all faces of the machining. So because he only uses 1 to 3 millimeters off the actual part, you can machine all faces of it. So actually today we might be using it actually, I'm not sure. And it's a dedicated fixture, so the way it works, when the ZeroPoint pulls it down, it closes the diaphragm and that will clamp, and you can use it in anger. Not only that, you have a quite generous depth of cut that you can use, so you can use for multiple, so you can do up 10 and up 20 as well. So if you're creative with the profile, and that allows you can cut one particular shape in one way, go a little bit deeper and cut another shape, and then flip the part over, or use for multiple items. Yeah,
because it's it does give a very good clamping force as well, doesn't it?
Oh, incredible clamping force. I should know by heart, but I don't.
I could tell you if you want.
It's you can use. It's not for finishing machining only. You can use it for all machining. And again, obviously, it's for the free forming, but it's much more than that.
Yeah, that's I've heard and I've seen it being used, and everybody raves about it and says how good a system it is. Well, Marcel, once again, thank you very much for coming along this afternoon. Thank you very much for enlightening us on your products that you have, and hope you keep supporting us in the future. Thank you very much indeed, Marcel.
Thank you.
Cheers. Thank you.
Bye-bye.
I'm now going to hand over to my colleague Andy. Andy.
Thank you, Graham. Thank you, Marcel. I'd like to introduce Tim Mitchell from Vericut. Good afternoon, Tim.
Afternoon, Andy.
How are you?
Yeah, very well, thank you. Glad to be here again. Always a pleasure.
Always a pleasure to see you, Tim. Vericut have been a big supporter of SolidCAM over the years, and we thank you for that.
Yeah, good partnership, yeah.
It's always been a good partnership. So, Tim, CG take Vericut. Could you give us an
Since
introduction to what you do,
1988,
what-
Vericut has been the industry leader in CNC simulation, verification, optimization, and analysis manufacturing software.
We're a California
Why choose Vericut? Whether you're a small job shop, OEM, or Tier 1 supplier, Vericut enables you to produce more efficient programs faster and get your products to market more quickly and competitively.
And optimization. That's all we do.
So you mentioned simulation. So simulation, why is it so important with verification?
Vericut eliminates prove-outs and saves machine tool, operator, and part programming time, all of which decrease your time to market.
NC tapes on the machine, and obviously this eats into valuable production time on the machine. So what we do is we build a virtual digital twin for your machine tool, which is an exact replica of your machine in the machine shop, and that allows you to verify the programs offline. And there's a lot of byproduct from it as well. You know, we can create reports and check the cut stock and stuff like that. So it's all about making customers more efficient and getting the product out of the door quicker and cheaper, basically.
Okay. So apart from verification, I know you have another product you offer, which is Force.
Yeah, we do, Andy. Yeah, absolutely.
So what is Force?
Yeah, so Force is a physics-based mathematical piece of software. And basically, it's all about optimizing NC code. So we take an existing program, we run it through our Force optimization module, and that allows us to look at the feed rates, make sure that the chip thickness is consistent, you know, as per recommended values from the tooling suppliers. And basically, there's sort of three wins, if you like. We're taking time out of the NC program. We're saving a lot of time, and also we're increasing the tool life and saving the machine from any high forces. So there's a lot that goes on, yeah. And customers are seeing great benefits from it.
Which size company who should be interested in buying Force?
Pretty much anybody, Andy, really. You know, anybody that wants to take time out of the process and make it more efficient.
So it's not just aimed at large machines?
Not at all. Anybody, really.
And it seamlessly works within your Vericut system? Absolutely,
yeah. You verify it through core Vericut, if you like, and then straight into optimization. So you just, in one software package, you know, gaining the results from that.
And just one final question then, Tim. You mentioned earlier you were purchased earlier this year by Samvik. How's that integration been?
Yeah, so far so good, yeah. You know, obviously getting bought out by a massive company like that, we can only see it as being a great thing moving forward.
Tim, once again, thank you for your time. Really appreciate it.
Thanks very much, Andy.
No problem.
Again,
thank you.
Great to see everybody. Cheers.
Thank you for that, Tim. We're now going to move into another demonstration. We'll be doing a sliding head demonstration on our Star ST20. Ben, if you could show that video, please.
Today we will run through the simple programming of this component in SolidCAM. We create a new mill turn part, then select the machine we want to use, in this case the Star ST20, and the date and position we want to set it to. When importing data, it could be in any orientation. This allows us to quickly determine which way around we want to set this on the machine, and we can easily toggle backwards and forwards to set either on the main or sub spindle. With this complete, SolidCAM will automatically create work envelope for the model, and in this case I've got it set to automatically define the material size. At every stage of programming, the programmer has access to the machine model. Here we can see where the material and part are located on the main spindle and where it is set to be gripped during transfer on the sub spindle. SolidCAM easily supports all the tooling for these styles of machines too through its toolkit. Here you can see a solid representation of a full assembly on there, including all holders, whether it's a multi-tool holder. So in here you can see a 3-tool turning tool holder. We can also represent exactly where that's being mounted on the machine through its machine preview. So here you can see a full layout of the tooling already mounted on the 3 different turrets of the ST20. To make life easier as well, you can copy full tooling assemblies and then move them to different locations within the machine. So here we're going to copy it and move it from one turret to another turret, This makes setting up tools very easy. So now let's add some machining to this. So first of all, we can add basic turning operations, and we can pick this area to machine directly from the model, selecting the first and last face. SolidCAM will automatically link that with all the faces in between. Selecting a tool is easy because we've already defined that within our toolkit you saw earlier, so it's literally just a case of selecting the tool from the list. We can do this on the fly if we need to and add this during the operation if we hadn't done it already. A few basic changes to parameters in there, so a couple of changes to offsets on there and depth of cut, and then we're away. We then have our full cycle all ready to be done. So a quick save and calculate will give us a preview of our toolpath as you see here. This could be simulated as well. There's several simulations available within SolidCAM. So we see here we're going to put this onto a basic turning, a very simple simulation which shows turning operations very clearly. So here you can see exactly what's actually happening. Creating a milling operation is basically exactly the same as we've just done in turning. So here we're going to machine the slots on there. So we select the face we want to work on and we select the geometry directly from the model. We only need this part because we have the power within SolidCAM to automatically extend that, or to give parameters, to give options to the user to add various lead in, lead outs, so we can extend this past this to do the front face on that. So I'm just putting some basic parameters in there, some heights on here, so machining down to the face selected there. And you'll see they've gone green. That's showing associativity. That will mean if the model was to change on those depths on there, then the toolpath would change with it. So as I say, we can add the extensions to the model on here. Basic save and calculate, and we can simulate exactly within turning. Another simulation mode we've got is to solid verify this. Now we can see this, machine this out of a solid block then, or a solid updated model on there. So here we go, and now we've got 3 of these to machine, so rather than programming 3 individual, we can simply copy these around the 4th axis on that, and that's now going to give us the 3 different orientations automatically. We haven't got to do anything else. So a quick simulation to check, and then we should be able to see all 3 of those positions fully machined inside SolidCAM. Okay, so a slightly more advanced feature on here. We're going to machine this slot going around the diameter. It works very similar to what we've just done. All we need to do is to tell it that the geometry we're selecting is wrapped around the Z-axis. SolidCAM will do the rest. Different selection technique. Rather than selecting edges on there, we can actually select a full geometry loop on that. So you can see that's now picked the whole of one of the edges of the slot for us. So the same as we've done on both the slot and on the turning, we're going to select a predefined milling tool on here. So in this case, just a 2mm ball nose, just to run around that slot. So that tool gets selected. We set our heights, so really all we can do is pick on the outside diameter on this. So that will give us the actual effective diameter, even picking anywhere on that outside face. So type in the depth, or select the depth if we needed to on there. It's automatically knows, because we've selected wrap geometry, that it's now going to be working around the C-axis. So it's done all that for us, and again a quick simulation and we can see exactly what we've got. So that toolpath is now going to be following that profile around the diameter. So now we've done a lot more operations. We've done all the machining on the main spindle, so now we need to transfer the part to the sub spindle. So first of all, we're going to pre-position the part and pre-select the tool for part off. So here we can see we're literally just selecting where we want to position the part off tool by selecting the face we're going to part off against on the part. Next part on there, we need to connect and bring up the sub spindle. Now we don't need to put any parameters in there, we just select the machine control operation to connect. All of our parameters have been done in setup right at the very beginning. So that keeps that very nice and easy. Third part on there is to actually perform the cut off itself. So this is just a SolidCAM operation. As we've done before, we're just going to select the geometry, select the tooling on this, but also extend the geometry so that it's make sure we're cutting all the way through the material on there, we're not leaving anything. So again, we use the auto extend onto that. As I say, we're going to select the tool, which is already defined for us on there. Now, very important also is we need to select the links, because we've just pre-selected the tool, so we don't need it to go anywhere else. We don't need any lead in, but also we want to leave the tool down so that it's actually finished and the bar feeder is pushing against it. One more operation, so that's the third one on there that we've actually done the part of. We now need to retract the subspindle with the part. So again, another MCO operation, retract subspindle. So that will bring that back. And again, no parameters. So that's now done the full transfer for us. Again, let's have a quick look to make sure what we've done is correct, so we can simulate this. Now this is our first look. We're actually going to look at this as it is on the machine. So you can see there we've got two views set up on that, so we can see very clearly what's actually happening. Hit the play button, and then we can see that first of all the part off tool is selected and positioned on the bar. Subspindle comes up, grips. Then we've got a part off and the subspindle retracts. With the complete part programmed, we now need to have a look to see how we're going to synchronize all the different options for it. So first of all on there, we'll have a look. This is programmed top to bottom. So what you'll see on there is the order we've programmed. So we're now seeing all the machining going on the main spindle. So again, a lot of this is happening sequentially. So then what we'll have is the transfer happening in just a minute, and then the work on the subspindle, which is absolutely fine, but it's not how you'd actually work in practice, because it's just not an economical way of working. So there's the transfer we can see going on now. The part is retracting, and then the subspindle coming in, or the upper turret coming in on the back. So now what we can do on there is, this is the order. You can see all the blue, the weight codes on there. So I've just zoomed this on there so we can see all three in one page. And we can now select a new workpiece on path 2 there. Delete the extra weight marker. We can now see that there's lots of things happening at the same time. So now there's things happening on path 2 at the same time as is happening on path 1 and path 3. But what we can also do, we can optimize a little bit more on path 1 and path 3, because there are operations which can be done at the same time. We can be drilling on the upper turret while we're machining on the lower turret. So now we can see the full part on there now being machined together, so we can see what the work going on the subspindle and the work going on the main spindle in one go. And we'll show you in a little bit more detail in just a minute, but there's superimposition. You can see it actually happening now, where the lower turret is compensating. It has its own Z-axis, so it's compensating for the bar movements which are needed to work for the work happening on the upper turret. So we'll have a quick look at that in a lot more detail now. So this is now finishing off. That's now done the part off on there. But if we zoom in on that particular area, we can see how it's actually working. So now we've got multiple turrets working together, and there's two Z-axes involved here, Z1 and Z3, and you can see Z3 is being compensating for Z1. Here's a quick video. This is actually happening on the machine. So now you can see the machine simulation is actually happening and showing what's actually happening on there. So the last part of this is, once we've got absolutely everything done on here, we can now generate the code. So this is now the code for the ST20. So now you can see all three channels highlighted and shown together on there. This is SyncMaster software which we can provide.
I'm now pleased to be speaking to Alec Warner from Star GB. Hi, Alec.
How you doing?
Very well, thank you. Alec, so sliding heads, which Star kindly given us an ST20 to demonstrate in our technology centre. These can be purchased from many different suppliers in the UK. Why would someone consider Star GB?
You're right, you can get sliding heads from 8 to 12 suppliers. It's what makes Star GB stand out.
for the business.
Good for us.
Absolutely. Is there a feeling in the market that sliding head machines are more difficult to set up than a standard CNC lathe?
I think going back maybe 10 or 15 years, that was certainly the case. I think a lot of CNC programmers, stroke operators thought it was a bit of a black magic. That's certainly gone these days.
Yeah.
The command system that we use, obviously our machines are 100% FANUC controlled, and it's 90% standard FANUC code with about 10% star command system. The star command system certainly has got a lot easier to make stitching programs together very quickly, very simply.
Yeah, and how important do you think after sales services?
It's vital. I think sliding head machine tool solutions are a little bit more detailed than the average sort of fixed head with a bar feeder on it. So certainly for new users, you've got to have that experience. You've got to know what you're talking about. That's why our staff, a lot of them go across to Japan to be trained. They all go to Germany to be trained on the bar feeders, because we sell obviously FMB bar feeders as well to complement our lathes. So it's really important.
Is that something you've developed over the last number of years, or is it always been a trait of Star GB?
It's been developed really by our managing director Steve Totti, who when he joined the company 20-something years ago, we weren't as good at support as we are now. He certainly put the plans in place over the years, and it's just got better and better and better. And I think that's what makes us stand out from the rest. Our guys know the machines inside out, and we've also got real good close ties to obviously the factories in Japan, our partners in Germany. We've become friends over the years, so we know where to pinpoint, put a bit of pressure on to get answers quickly for our customers.
What are the limitations in terms of size and complexity that your machines can produce?
In terms of size, you're looking at components, 0.5 millimeter wide up to theoretically 6 meters long.
Yeah.
We offer bar feeders that go from 2 meters to 6 meters, and if you can handle that length of component at the other end of the lathe, you could theoretically make that part. I mean, we've certainly done shafts in excess of 2 meters,
right,
up to 40 odd millimeters in diameter. So there's a massive range of parts that the machines can do.
Right. Are Star machines compatible with Industry 4.0?
They are. We've got our own piece of software, monitoring software. It can also do other FANUC controlled machines. We launched that 2 or 3 years ago, and we've got several users now in the UK. And you can monitor the machines obviously on your tablet, smartphone, desktop PC, whatever. So it gives you full traceability of the cycle time, the efficiency of the machine, any alarms that keep popping up on the machine. So it gives you the full SP basically on all the machines in the shop.
And what new technology on the horizon from Star?
We'll be launching 2 new models in the coming weeks. We've got a succession model, which is our SR32J3B. That's our most popular machine by far this year. That model is changing. The backworking pattern has changed a little bit. It's more rigid now. The casting's a little bit heavier, etc. And then we've got brand new machine, the SL series, that's going to be offered in 7mm capacity and 10mm capacity, SL7, SL10. So that plugs a little gap that we had in our portfolio in the sort of smaller diameter ranges. Yeah. We're really happy to see that machine come into our model range, and we think it's going to be a really good seller. It's a real versatile piece of kit in a very small compact footprint.
Do you feel as though once that comes in on board, you'll have a full range then that will be able to complement all your customers' requirements?
That's a good question, because customers always want that little bit extra,
more,
don't they?
Absolutely.
But yeah, it certainly fills a little gap we had in the small parts section. Obviously, we've got the SR10J, which was our smallest machine previously. But this model, you can attach all different sort of tooling cartridges to it. It's got 3 or 4 modular stations on the platen, so you can thread wool, gear hob, you name it, you can do on it, which wasn't quite as easy on the SR10J model before because of the sort of nature of the layout inside the machine. So we think it's going to be really competitive, and we've already sold quite a few machines, even though we haven't had one land in the UK just yet.
Sold them the dream.
Yeah.
And final question, on the FMB, what's much on the horizon from FMB?
There is the SL7 and the new FMB bar feed will be on show at our open house first week of November. On the FMB side, we've got a new model. It's called a Turbo RS. The technology on this bar feed is a little bit different in that the bar feeder channel's got a moving section on it that attaches to the back of the headstock of the lathe, and this basically moves the support point closer to the business end.
Yep.
Obviously the main collet and the guide bush. So it's a combination of two technologies that FMB have had in their portfolio for a long time, but we think this could really hit the spot, certainly on the sort of 36 size machine, which we sell most of. So,
well, Alec, thank you ever so much, and thank you again for supporting SolidCAM on our open day, and we look forward to many more.
You're more than welcome. Thank you.
Thank you. Well, that was Alec from Star. We are very fortunate to have an ST20 in our technology centre here in Barnsley, and that has been tooled by ISCAR. I'll now be speaking to Darren Taylor from ISCAR about the tools they've provided. Good afternoon, Darren.
Good afternoon, Andy.
How are you?
Very well, thank you.
Once again, thank you for supporting SolidCAM today.
It's been a very good event, actually. I really enjoyed it.
I'm glad you've enjoyed it. Tell me a little bit more then about the tool lines you've supplied us for our sliding head machine.
Well, we've been established in the sliding head tooling market. I've been with ISCAR 25 years, and we've had dedicated Swiss tooling for that whole time. And it's really been driven by the industry of trying to keep the spindles running all the time. So there's a couple of examples there. Both of these are standard tools, but they have quick change inserts in them. So a traditional SDJCR would have a screw clamp.
Right.
But what we've done is we've made it a lever lock. So you don't need to remove the tool from the machine.
So you can leave the tool inside.
Leave the tool in.
Change the tip.
Without, the typical thing with an SDJCR is you drop the screw. There's no screw to drop.
Okay.
So it's been, all the tools are aimed at quick change.
And that, obviously that's ease of use for the people, far better.
It keeps the spindles running, they're earning money, and that's what it's all about.
Absolutely. And what about the repeatability of the tools?
If you take our standard Swiss cut range, the inserts repeat to within 25 microns in length and in height. So once you've set the tool up, within a box of 10 inserts, they'll repeat to within 1,000. So there's no need to re-establish tool heights on the machines. You index the insert, you carry on machining as quick as you can.
That's fantastic. And how are you seeing the market, Darren? Is it buoyant for yourselves?
It's very buoyant, especially the miniature industry. And more people are looking at the class of these machines, being able to finish a part in one operation.
And is this something that ISCAR have put a lot of investment in over the last number of years?
We have, and I can announce that very soon we will have a complete new Swiss line of quick change tools as well. So although we've got, I see the premier line of tools at the moment, we're upgrading these already. So we're pushing the boundaries further for a faster turnaround on insert changes.
So obviously ISCAR see it's a big development for yourselves, and obviously a big investment, and that's good for the market.
Exactly, it's fantastic. It's really good.
That's good. Well, Darren, thank you for your time today. Many thanks for supporting SolidCAM once again, and we look forward to many more times in the future.
Thanks, Andy.
Thank
Cheers.
you. I'll now pass over to Graham.
Hi, good to be back again. Unfortunately, the representative, Stuart G. from Trent Lubricants can't be with us this afternoon. And even more unfortunately, he's not left a presentation video for us, so you've got me for the next couple of minutes, I'm afraid, talking about Trent Oils. Now, the reason why Trent Oils are here today is A, they are another good partner of ourselves, and B, they have a good working relationship, a very good working relationship with Star Micronics. I'm going to stick my sales head on just for a second here, and just say, our representative, excuse me for a sec, Alec, from Star Micronics say that I'm allowed to say this, that if you buy a new Star, you get a free full barrel of Trent lubricant oils with your machine. Sales pitch over. Yep, it's all too often in the manufacturing industry that people overlook the importance of lubricants, coolants in the whole system. Today we've seen top-end machine tools, quality cutting tools from Iscar, tool holders, work holding from Shunk. And then it comes to the coolant, and you hear so many times people saying, well, it's just coolant, you can just use anything. Well, it's not the case. You know, coolant is vital. Trent Lubricants keep a very high standard in their coolants, and it's something that you shouldn't just bat away, because if you've not got the right coolant, you've not got the right lubricity, the right mix in your coolants or your oils, you're heading for disaster, especially in intricate and really high accuracy parts. So I'm not going to rabbit on for too long about Trent Lubricants. They are important to us as part of our setup. They're obviously very important to Star Micronics. If you see a barrel with Star written on it, it's Trent Lubricants that's in it. So they do value the relationship very highly. So, and like I say, unfortunately, we couldn't have Stuart here with us. He had to leave. But we do value your support, and thank you very much to Trent Lubricants. So moving swiftly on, we're coming to the end of the day. We had the event this morning, as was mentioned earlier, and the event this afternoon. We thank everybody for turning up today, the customers. We very much thank all our partners for turning up again today and supporting us in every way that they can, and all the new technology they bring along. You've heard them all speaking about it, and the next time we're here, there'll be something new again. And I'd just like to say, you know, thank you to them. Thanks for the support, and we'll see you again the next time. Thank you very much. From SolidCAM, we've had a brilliant day. Thank you for watching, and thank you for listening all over the world. Thank you. Bye-bye.